Hello there. So we have our next kind of virtual lab or computer-based lab activity. This is kind of our second one for our current chapter. We just got finished with kind of studying how the molecules in an environment, particularly carbon dioxide, kind of understanding how it moves throughout an environment and how it plays a role with global warming. We know global warming causes potential survival issues for species on the planet. Research is currently being done to kind of investigate that. But I figured we could also investigate another thing that could potentially affect the environment and species survival. Like carbon dioxide, other molecules can impact an environment and can do damage to the cells of an organism or the organism overall, its entire body. So that's what this activity is about. It's about studying how certain molecules or charged atoms in an environment can potentially do harm to populations or even cause extinction. And those chemicals relate to something called pH. So that'll be our environmental kind of issue is pH and how it affects organisms. The activity is right here, as you can see. It's at the top of our Google Classroom page. So it's right here. And let's click on the worksheet. The worksheet has a quick link. And all you gotta do, it's a Google document. You just click on the link. You left click it. You don't have to right click. You just left click it and then go right here. Click on it and it'll take us to the website. And here we are. Let's scroll down a little. So with any good research project, it starts with an overall question. How do population changes of aquatic invertebrates indicate water quality? What that is saying is, when organisms start dying in the water, what might be causing it? That's the problem. That's our scientific question that's kind of leading our investigation. So we really just want to understand more about what water quality says and what's in the water, the possible atoms or molecules in the water itself that might cause problems to species and their populations. So let's return to the worksheet, and the first thing it wants us to do is indicate that scientific problem, which we just indicated. So go ahead and type that in if you haven't yet. And it says collect data to better understand the problem. So we want to understand how water quality is affected by certain things dissolved in it. In this situation, we're dissolving something in the water that affects the pH. And that's what it says right here. It says carbonic acid. So carbonic acid is a carbon-based substance or compound that when added to water affects the pH. As you can see here, the pH starts at 7, and that's pure water. The pH slowly goes down. So it's a rating system indicating the amount and effect of this carbonic acid. As you add more drops, the carbonic acid affects pH. You can also see that there's 6 total species you're going to investigate. As it says here, it says to get 6 species, you'll have to reset the simulation and start with 3 new species after that. And the 3 new species, the first one will represent species 4, second 5, and third 6. So let's look at it for a little bit. So we have 3 here, but if you reset it, so you could study these 3. You could see what the effect of carbonic acid has on the pH of the water, and how that carbonic acid and the pH not just affects the water quality, but how the survival of the species, or any species going extinct. Once you've done that, once you've collected information for these 3 organisms here, and you've filled out the information for species 1, 2, and 3 for different pHs, remember what the number you're putting in here is how many there are. Let's say the population started with 10. So if there was 10 individuals, then you go down to pH 6.7, you get 15 individuals, right? And of course here you got to type in what the species is. Now the question is, what are the first 3 species? So you go to the activity, you click right here, and it tells you. Species number 1 is called dragonfly nymph, so it's an insect. Species number 2 is a stonefly nymph, another insect. And then the species number 3 is a crayfish, and that's kind of related to, it's similar to a bug, but it's you may think of them as like little shrimp with claws. All right, and you can see each species, there's 20 of each at the beginning, so a pH of 7, so it's pH of 7 you would put for species 1, which is dragonfly nymph. You'd label it. Whoop, that's not the right thing. So you'd put dragonfly. This would be stonefly. It'll be different for you. It's random which species appear for the first 3, and then here you can put crayfish. There you go. And at a pH of 7, there's 20 of each. All right. And then as you go and adjust the pH, you'll find that the population amounts change potentially for each species. Let's go back to the simulation. So this tells you how you know how many individuals there are and what pH. All you have to do to change pH is just click on carbonic acid. And you can't do it a bunch of times because you want to go slow so you can measure the pH level properly. So just keep the computer screen open. And again, all you do is click on the computer screen to get it. And then you just got to tap this once, and it does all the magic for you. So we just changed the pH to 6.7. So in the data table at 6.7, boom, you'd indicate how the dragonfly, stonefly, and crayfish population has changed. According to this, the crayfish don't like adding acid to the water. They don't deal well with carbonic acid. They don't deal well with the reduction in pH. So the population drops a bit. And you can see these 2 species still at 20. Nothing's happened. And then you'd go again, second round, you just tap it, you just tap the dropper, and it reduces the pH again by 0.3 points. So it's now a pH of 6.4. And you currently have ghost crayfish. They're all gone. They've gone on to a better place, hopefully. So they're all gone. The species has gone extinct in this environment. All right. Again, when you continue to, you have to do the dropper until you get to a pH of, let's see what it says here, 2.8. So keep adding drops until you find out if any of the species can handle the pH at that level. Once you're done with that, and once you figure out how the species respond to each, you just reset it. And in this situation, it gave you a crayfish again, and it gave you dragonfly nymph. But you already have data on those, so you have to reset it again if you get a repeat. So I'm repeating it. Well, you got a repeat of dragonfly and stonefly, so let's see if we can reset it again. We keep resetting until we get new species. There you go. So I hit it a few times, and now you have fairy shrimp, tubifex worm, and leech. Ooh la la. Alright, there you go. You basically continue this process until you get the data table filled out. So when this whole thing is filled out, just take a little bit of time, you'll get there. And the next thing is to read about this information. It has to do with acid rain. So acid rain, it has a similar effect as in this experiment. So in the experiment, you're adding carbonic acid to this environment. But in nature, you have something called acid rain. And this is the story of how acid rain forms. It talks about, and you'll find that it's kind of connected to fossil fuel use, just like global warming is partly related to carbon dioxide in the atmosphere, more and more carbon dioxide molecules in the atmosphere. You'll find that certain compounds or molecules, when they're in the water, they affect the pH, and those molecules or compounds or atoms, those charged particles, they can also cause issues, right? Which in your data table, you've already found that out. You found that, I mean, some species won't do well. So you read through this, and then you're going to underline or highlight unfamiliar words. And underlining might be the easiest thing, or you can just color the text. So any words in here that you don't understand, you're expected to underline or highlight or change the color of. Then you'll get a signature from me. And then after that, you read through, and it guides you into kind of thinking about comments or information for certain paragraphs. in this situation wants you to study paragraph 1 and paragraph 3 and read it closely. And then I want you to go through it again and look for two of the words that you underline or highlighted. I want you to define them. Be careful though, when you put the definitions here, first put the word and then the definition, but you have to go on the internet to find a definition. Let's do that. Let's do an example of how the best way to approach this. So let's pick a word here. I'm going to do, let's see here. Let's do pH. We'll just keep it simple. Let's look up the definition for pH. So I just type in pH definition. Now look at this right here. Okay, this definition says a figure expressing the acidity or alkalinity of a solution on a logarithmic scale. Now, that should not make sense to you unless you've been studying high-level mathematics in high school. A logarithmic scale may or may not make sense. The term alkalinity may not make sense. We've heard acid. We know citrus are acidic fruits. But overall, this definition doesn't make a lot of sense. So, what do? The goal is to find a definition that makes more sense to you. There's no point to write it down if you still don't know what it means. So in picking a definition, it's tricky. You want to find one that makes sense to you or helps you understand what pH means the most. So you got to shop around. Do not pick the first option. You kind of cruise through. And you may or may not find the one you like. If you feel like they're all pretty confusing, you have another choice. You could talk to me and we could discuss it. This one ain't too bad. A measure of the acidity or alkalinity of a fluid. The pH of any fluid is the measure of its hydrogen ion concentration relative to that of a given standard. That's a little closer. But if you still don't like the definitions you get, and I'm suggesting you get a simple, straightforward definition, use the textbook. The textbook has a definition for pH, or just talk to me and I'll help you. But again, the goal is to get a definition that makes sense to you. If you're writing down a definition that's so complex that it doesn't make sense, there's really no point in looking the word up. So you got to shop around, pick the one that makes the most sense to you. All right, here you go. It says summarize the ideas of each sentence where the highlighted term was found. So the goal is to go back where you found one of the words. Like pH is used often, but you could say, let's see here, let's read the first place. Oh, the pH scale. So the strength of acid rain is determined by reading a pH scale. So you could say, oh, I realize now that pH has to do with hydrogen particles or atoms, and I realize now that acid rain has to do with hydrogen. So then you could go back and now don't use this sentence I'm giving you. Do it on your own, but you get the idea. And then I would write here, okay, in sentence such and such, or sentence 1 of paragraph 3, I now know that. That's all you gotta do. You gotta share your improved understanding of the sentence now that you define the word. Here is your typical summaries. You guys are terrific at summarizing information. So look at paragraph 3. What are the important ideas from it? Put it in your own words. Original idea here. Paragraph 4. Original ideas here. And then if you had to give a one-sentence description of what the article is about, or what does it focus on, and what does it improve the understanding of, that's all you do here. You just summarize that part. Very simple. I'm having you summarize paragraph 3 and 4, and I also asked you to answer questions about paragraph 3 and 1. So I'm already telling you that's my way of telling you those are the more important ones. Alright, in the end, based on your readings and your lab research, I just want you to share a report, basically, and it's a first draft, right? Look at this, it says first draft only, so don't put an intense amount of pressure on yourself to make it perfect. I just want you to report on your results and your better enhanced understanding of what the results, what caused the organisms to be harmed or the populations to change. What is acid rain? What is pH? Based on your reading and your research from the data table, hit each one of these points in your report, and you can talk about 1 by itself, 2 by itself. It doesn't have to be